In 2023, astronomers pointed one of the most powerful telescopes ever built at a region of space they thought they understood. What they found didn't fit any model, any theory, any explanation they had. It wasn't a planet. It wasn't a black hole. It wasn't a star. It was something that, to this day, has no name. This is the story of what happens when science finds something it isn't ready for. For decades, scientists operated under a comfortable assumption that the universe, as vast and strange as it is, follows rules we can measure. Gravity, light, time. These were the pillars of our understanding. But every so often, the universe sends us something that quietly dismantles everything we thought we knew. In 2021, data from deep field observations began showing an anomaly, a signal, or rather, an absence of signal in a region of space that should have been perfectly ordinary. Galaxies were behaving differently. Light was bending at angles that didn't match the mathematics. And right at the center of this anomaly, there was nothing visible at all. Now, scientists don't use the word mysterious lightly. They're trained to look for rational explanations first. But after months of peer review, the conclusion was the same. Something is there, we just cannot see it, measure it, or explain it. The question isn't whether it exists. The question is, what is it? To understand why this discovery matters, we need to talk about the hidden architecture of the universe. Everything you have ever seen, every star, every planet, every galaxy captured by every telescope accounts for roughly 5% of everything that exists. The other 95%, we call it dark matter and dark energy. Not because they're dark in color, but because they are invisible to every instrument we've ever built. We know dark matter exists because of what it does. It bends light around it. It holds galaxies together. Without it, the Milky Way would have torn itself apart billions of years ago. But we have never directly observed it, never photographed it, never touched it with a single detector on Earth. And now, something that may be connected to that invisible universe has appeared, in a place where it simply should not be. The anomaly doesn't behave like dark matter. It doesn't behave like dark energy. Some physicists have suggested it could be evidence of a fifth fundamental force, one that doesn't exist in any textbook written today. Now, when something defies explanation, science does what it always does. It generates theories, tests them, and discards the ones that don't survive. Let's walk through the three most credible explanations currently being debated, and why each one, if confirmed, would rewrite a different chapter of physics. Theory 1. A primordial black hole. These are hypothetical black holes formed not from collapsing stars, as most black holes are, but from the extreme density of the universe in its very first second of existence, before any stars, any planets, any structure had formed at all. They have never been confirmed. No instrument has ever directly detected one. But the mathematics allows for them, and if they exist, they would be unlike anything else in the cosmos. Ancient, invisible, and carrying within them a record of the universe's earliest moments. If one is responsible for what we're observing, it would be the first primordial black hole ever identified. And that alone would be one of the greatest discoveries in the history of astronomy. Theory 2. A gravitational lens. So this is the idea that there is an object, or a dense cluster of objects, positioned between us and what lies beyond, bending and distorting light in a way that creates a kind of cosmic optical illusion. Gravitational lensing is real and well documented. We see it regularly around galaxy clusters. But in this case, the numbers don't work. There is no visible object with sufficient mass to produce the degree of lensing we're observing. Which means, if this theory is correct, the lens itself must be made almost entirely of invisible matter, dark matter, concentrated in a way we have never seen before. Theory 3, and this is where it gets genuinely uncomfortable for physicists, is the possibility that what we're looking at is a region where the laws of physics themselves are subtly different. Not broken, not malfunctioning, just different. In the moments after the Big Bang, as the universe rapidly cooled, the fundamental forces of nature separated and settled into the forms we know today. Some theoretical physicists believe this process wasn't perfectly uniform, that in certain pockets of the early universe, the roles crystallized differently. Regions where constants we treat as fixed might have slightly different values. Now, if such a region exists, and if we are observing one now, it would mean the universe is not as uniform as we assumed. It would mean the laws of nature are not universal. And it would mean every model of cosmology ever written would need to be reconsidered from the ground up. None of these theories have been confirmed. All of them are, in the strictest sense, possible. And the fact that we cannot yet eliminate any of them tells you everything about how genuinely unknown this territory is. What's remarkable isn't that scientists don't know the answer, it's that every answer they reach for opens a door to something stranger. Now you might wonder, well, why does this matter? It's far away, it's invisible, it affects nothing on Earth. But here's the thing. Every time we've discovered something we couldn't explain in space, it has changed life on this planet. Pulsars led to atomic clocks. The search for dark matter led to cancer-detecting sensors. Understanding black holes gave us the mathematics behind MRI machines. The universe has a habit of hiding its most useful secrets in its most confusing places. And whatever this anomaly turns out to be, a new force, a new particle, a new kind of object, it will almost certainly change how we understand everything else. Now, we began this video looking at a region of space that had no name, that still actually has no name. Science is not always about answers. Sometimes it's about sitting with a question long enough to realize how extraordinary it is that you're even able to ask it. We are a species standing on a small rock in an ordinary galaxy in one corner of a universe that is 93 billion light-years wide. And we are asking, what is out there? Now that question has no final answer. But every now and then, the universe gives us a new one to work with. If you want to go deeper into the nature of dark matter and what it means for the future of physics, that video is right here. And if you haven't subscribed yet, this channel exists for exactly these kinds of questions.